The next is the host level security. So, when the most important host level security is, so the host can be used in three forms. I can use it just as an infrastructure, I can use it as a SaaS or a PaaS, like software as a service or platform as a service or infrastructure as a service. Now, the security becomes extremely, from a cloud service provider's point of view, the security becomes extremely complex when we look at the infrastructure as a service host security. When I give an infrastructure as a service, how will that whole infrastructure look like? First and foremost, there will be the hardware. On top of this hardware, there will be a virtualization software. This is called the hypervisor. Soon we will see a block diagram there. The hypervisor is responsible for the virtualization. So, the hypervisor will provide several virtual machines to the operating to the higher layers. So, the hypervisor is one who is responsible for the upper layers to look at the single physical machine as multiple machines. So, on this hypervisor, which is also called the virtual machine manager, you can actually instantiate several virtual machines, and each of these virtual machine can start executing different software, or each of these virtual machine can run their own operating system on which the own software can be run. Now, we have to look at the security at that level of the hypervisor level, and then comes what we call as the customer guest OS or the virtual server. And the in the IaaS type of model, the customer has complete control over the virtual server. Now, whatever I have told here could be best explained with a figure, and this is the figure here. Now, you see that there is one single hardware which is in the bottommost rectangle. That hardware can be a symmetric multiprocessor machine, multi-core machine. It has physical memory, it has all peripherals like your disk, your Ethernet, and it can also have different varieties of things, like it can be a non-uniform memory access machine. So, it could have several memory banks. So, that is an architecture. On top of this hardware, there is the actual what you call as the hypervisor. The hypervisor is also called the VMM, which is the virtual machine manager. And what will this hypervisor has lot of interfaces to the upper layers. There is a control interface, there is a safe hardware interface, there is a event channel, there is a virtual CPU, virtual memory management unit, and then the hypervisor. So, that is to the higher layers, that is software that is going to run on top of it. And the interface to the lower layer, there are two interfaces, one is the x64 and the x86, which is your IA32 and IA64 bit architectures. So, the hypervisor is an interface with the hardware and the upper layers. What is the role of this hypervisor? We will talk much more on the architecture of hypervisors in our level 2 or level 3 courses in great detail, but for our understanding now, an hypervisor is one responsible for creating several virtual machines on the top. Now, in this instance, as you see in figure, there are 4 virtual machines that are basically generated or instantiated. So, you see there are and these virtual machines can do different type of activities. All these virtual machines, the one you see that the virtual machine 0 can be just a device manager and a software controller. Then you have virtual machine 1, virtual machine 2, virtual machine 3, it can be for 3 users. So, the one virtual machine which is on the left hand side is for the administrator and the remaining 3 could be for the user. And each of these virtual machines, so 4 virtual machines are running. So, the administrator and the 3 users will think that the server, that hardware is exclusively for them. They will not even know the existence of the other virtual machines that are running. They are isolated from the other virtual machine. Now, your hardware is very fast. So, your hardware can actually run 4 software at the same time, but if I try and run and these 4 softwares are not on the same operating system, one can be a Windows, one can be a Solaris, another can be a Unix, but all these 4 softwares can run at the same time on the same server, and these 4 softwares will be compatible to different operating systems. So, essentially what it means, I have one physical machine on which 4 different operating systems are running, and each of these operating system there are 4 different software that is running, and none of them know the existence of another, and all these are running concurrently. So, in essence we are giving a virtual machine to each of these software, along a virtual machine in the sense I am giving a hardware and an operating system to that, and all these virtual machines are isolated. So, this is the actual model. Now, when we look at it, when we use this as an IaaS, that is infrastructure as a service, then the hardware is an infrastructure, then there is an hypervisor, we have to look at the security there. If there is a security lapse, everything is gone. So, so user 3 in your figure, the user 3 can read the data of user 2. Who is providing that isolation? The hypervisor is providing the isolation. If your hypervisor is compromised, everything is gone. Now, the next thing is at the user level, again the user has complete access to the server or the operating system, and so sufficient security needs to be provided so that the operating system, the user does not compromise, the user cannot easily get or hack into the operating system and come and start doing something on the other virtual machines. So, this is the actual challenge when we look at providing host level security at the IaaS level, when the people are using your cloud as an infrastructure. So, just summing up, there is an hypervisor level security, and that security is very important when you look at multi-tenant architectures where more than one software runs on the same physical hardware. And then there is the next level, which is the customer guest OS or the virtual server, and we have to look at security of them. So, when the customer has an access both to the operating system and the software, so what he installs inside the software, what he installs, how he configures the operating system, is the operating system hardened enough, all these things are not under the control of the cloud service provider in this infrastructure as a service model. So, that makes from the cloud service provider's point of view, it makes security a larger concern, because if he assumes that the customer can be malicious, or the customer does not know much about security, he has just installed a very light unhardened operating system, then somebody attacks from outside into his software or somebody internally attacks into his software, then that is going to be a compromise. So, for a cloud service provider, the security becomes a major concern, much more larger than a larger concern when the customer is going to use him in the infrastructure as a service model. But if the customer is going to use the cloud service as a software as a service or platform as a service, then the cloud provider has much more control. If it is as a software as a service, it is absolute control, everything is his, the software is his, the operating system is his, the guest operating system is his, of course the hypervisor and the hardware. If even as a platform as a service, then again the operating system is his, the server is his, so only the software is going to come from outside. So it is easier from the cloud service provider's point of view, it becomes much more easier to provide security in this SaaS model and the PaaS model rather than the IaaS model. But on all these things, finally the owner who is the customer, if he is doing if he is not just come to the data center with malicious intent of trying to break into other virtual machines, genuinely trying to provide some service to the to his customers. So let us say a bank has its own customer. Now this bank is a customer to a cloud service provider, then from the bank's customer point of view, the bank is ultimately responsible for all the security. So the bank believes in the cloud service provider to give the security, right. So this is the thing. So imagine a cloud service provider with one using the cloud as an IaaS and another using a cloud as a PaaS. So in the case of IaaS, the cloud service providers does not have the responsibility of configuring the operating system and the software, but then he always has a fear that can be very loose or less hardened and people can enter if there is a vulnerability. On the other hand, in the same machine he may have another client who is using it as a software as a service, and he has to provide absolute security because the customer, now that another client believes in the cloud service provider for giving the necessary security. So this is the major challenge when we look at cloud as an service, cloud service from a security point of view. Now this is one very interesting case study, it is called Amazon's EC2 case study. So here this is the you can just search Google on hey you get off my cloud, exploring information leakage in third party compute clouds, and you will find lot more things here. So this is a very interesting, so just to sum up what is there in the slide, you can read the slide, but I will give you a sum up here. So the ultimate objective of an attacker is to go and so this is a multi-tenant model, is to go and instantiate a virtual machine. So I am targeting one software, say software X of some customer A. This software X is running on one particular physical server as a virtual machine, and that physical server has a multi-tenant model. From outside I would like to go and instantiate another virtual machine on the same physical server in which X is running and try and start attacking it. So one of the interesting thing one can do is to keep on spawning many virtual machines into the cloud and then find out an IP address and find out the patterns. If two virtual machines which are installed on the same physical server, every virtual machine will get an IP address, they may get the same very close IP address. So one will be say 192.18.16.14, another will be 192.18.16.15. Like that we would like to do some cartography here and try and find out which exact physical server is the software X is running, which virtual machine in which X is running, and I would like to instantiate a virtual machine on the same server so that I could now go and attack X in a very good physical proximity. So this is what this case study is all about. So you can read about this case study in much more detail in the website, just Google for that and you will get it. The next thing that we have to look at is of course local host, right. So, many of us are accessing, so iCloud is accessed through iPad for example. So, there are all the clouds or public clouds are accessed through different machines. Those local machine security, are they important or not important? Are they part of the cloud infrastructure? The answer is yes, because through them somebody can access the cloud. And do they need to be protected? Yes, they need to be protected. Can they attack other local machines on the cloud? Yes, they can, because electronically there is there is a channel through this local host into the cloud, and that is enough to go and start exploring or crawling into this cloud. So, and very important to note that today desktops are basically வருதா ஆன் பண்ணியா சரி என்ன பண்ணலாம் இதில் இங்கேன்னு பண்ணுறேன் லோக்கல் ஹோஸ்ட் முதல்ல சரி இந்த லாஸ்ட் ஸ்லைட் கட்டு இந்த ஸ்லைட்லேருந்து ஆரம்பம் ஓகே இன்னும் நம்ம 3 நிமிஷம் பேசணும் இல்லையா 10 நிமிஷம் இருக்குது சரி 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 கரெக்ட் தான் ஸ்டார்டிங் அகெயின் இந்த ஸ்லைட்லேருந்து okay. There are lot of local hosts which are connected to the cloud. Are these local hosts part of the cloud infrastructure? Should they be protected? If they are not protected, can somebody attack through those local machines into the cloud and other local machines which are connected to the cloud? The answers to all this is yes, because the local host, for example your iPad which connects to your iCloud, all your handheld devices which connect to your point of sale terminal which connects to some cloud. So, all your machines are access points to your cloud, and if somebody can enter through that into the cloud, it paves way, and the moment they enter into the cloud, then there is a possibility for them to go and attack the cloud, attack the other machines connected to the cloud. And very interestingly, you note that handheld machines, handheld devices are not as secure as a desktop. So, it is very because the simple thing is when it is stolen and you actually made all your password, you make the handheld devices remember the password etc., then obviously the moment it is stolen they can get access to your cloud. The person who steals it can get access to your cloud, get access to lot of your credentials. So, it is very important that your handheld devices are kept very safe. Now, so how do we go and handle this? So, when we look at local hosts today, either point of sale terminal or tablets, you look at secure tablet etc., we should have some strong authentication mechanisms here. So, when you want to log in, there should be multi-factor authentication like your fingerprint or NFC card etc. Then there should be some tamper resistant mechanisms, nobody can open, when you open some secret keys that are used for security should be erased etc. And then there should also be a strong isolation at the server end between applications. So, somebody comes through one local machine and start accessing one application, it should not go and affect another application. And the OS at both the host end and local host end and the cloud should be trusted, and there should be lot of cryptographic functionality, especially when traffic confidentiality is required. So, all these things can make your cloud very secure. So, to sum up what we have done so far on the host we have looked at the host at the cloud, we have looked at the server, hypervisor, hardware, hypervisor, operating system and software infrastructure at the cloud side, and we are also looked at the local host side, which will be accessing the cloud from outside, and we looked at some of the security concerns here. The last to just do here is the application level. What do you mean by an application level security? The applications should be secure enough such that through them there should not be a denial of service which will be disturbing the application. So, the application should be available, and then there is also something like an economic denial of sustainability. What happens is an attack against the billing model that underlies the cost of providing a service can go and kill the service itself. So, for example, say I am looking at electronic metering. So, I go and keep resetting the meter value, then the whole electricity department can go for a loss, right. So, that is another application. So, I am running applications here, and those applications, the data that they are getting and the data based on which they are making certain decisions, all these to be protected. And then of course, the end user security. So, end user logs into your cloud, it is again an application, login is an application as far as we are concerned, and that also should be, there should be lot of authentication and protection, that is credentials are not stolen. And so, the question now comes is, who is responsible for web application security in the cloud? When we are looking at SaaS, PaaS and IaaS, in all these models the application security rests with whom? In SaaS it can be the cloud, is it not with the user or the customer? In PaaS is it with the cloud or with the customer? In IaaS is it with the cloud or the customer? And if you have customer deployed application, who is responsible for the security? Now, these are all very important things. I go and put an application running on a cloud, or in the IaaS model or the PaaS model, or I run an application which is given by the cloud provider, then finally in all these three contexts, who is responsible for that security? So, these are some of the things that we need to understand in great depth. So, for us to appreciate application level security, we may have to go and look at the data life cycle in great detail, where it will give us pointer about security at the application level, and that we will see in the next session.